So by way of introduction, my name's Brian Cherry. I am Senior Business Development Manager for AGD Systems. I've been in the ITS industry for some 20 years, 10 of which was spent with Siemens Traffic here in the UK. And thank you to Ryan for the introduction, and also to all of you for joining us today for this Coffee with Coral session. I'll introduce Dean as well, Dean Jarvis. He's our commercial engineer. And he's going to be covering the body of the presentation today in terms of a lot of the technical stuff that's in the presentation. So if that's okay with introductions, without further ado, we'll launch into the presentation. So the first couple of slides are very much just an introduction to AGD Systems and the company, who are based here over in the UK. And we're part of a bigger group called the Traffic Group. And you can see AGD over there on the right-hand side of that little graphic there. We're a privately owned company with 125 employees within the group. And we do actually pride ourselves very much on the amount of money we invest back into R&D and into product development. There's several new product developments currently underway that we're going to introduce into the industry in 2021. We've won 3 Queen's Awards for innovation over the 30 years that we've been established in the UK. And we sell a whole range of products, numbering some 30,000 annually. And the range of those products range from $120 up to $20,000 each. Just a bit about that graphic on the right-hand side. So the Traffic Group of companies comprises really 2 arms. On the left-hand side, you can see it's very much about portable traffic signals, so temporary and portable traffic signals, the roadworks when the roadworks are going on. And those companies there provide, they supply and hire temporary traffic signals for those roadworks. And there's also a service company there on the left-hand side. And then on the right-hand side, you can see where AGD sit. That's our sensors and technology side of the business. And within that group of companies, there's also AGD Australia. It's a wholly owned subsidiary company based in Australia, covering the Far East, Malaysia, Singapore, Thailand, that sort of region. Then there's a company called Radix Traffic, where I was managing director for 10 years. And they sell rotating cone tactile equipment to help blind people cross the road at pedestrian crossings. MAV are a CCTV company. They supply quite sophisticated CCTV cameras to the likes of Siemens for the congestion zone, for example, in London and other cities in the UK. And that's really probably about it on the right-hand side. So that's a very brief overview of the Traffic Group of companies. Next slide, please, Dean. Now more in-depth really overview of AGD Systems ourselves, and we go across all areas of the ITS industry. You can see there across the top, including enforcement products. So the sort of UK approved enforcement products for speed signs on the motorway and giving everybody those wonderful tickets as they're speeding down the highways. We are pretty much number one. Well, we are number one in the UK in terms of overhead above ground detection products. So we've been established for 30 years. Last year we turned over 8 million. And this year, actually, despite the COVID situation, we're forecasting probably in the region of 10 million. So a significant improvement on last year. That does include a significant amount of exports. We are growing our export business year on year. We hope to, well, we're currently, I think, about 20-25% turnover is export. And we're hoping to increase that to about 30% in the next couple of years. And that's probably one of the reasons why I'm here is to try and grow the business in the US and Canada. So North America generally is my role to grow the AGD business in that region. I've already mentioned about R&D, and as I say, if you look at our manufacturing facility, you'll see that each product has its own production test area. So there's probably $15,000 to $20,000 worth of test equipment on each product in the factory. And we do pride ourselves on delivering, if you like, a very high quality, highly reliable product that will last for many, many years to come.
Yeah, just as a note on that, Brian, our big machine, Athena, which tests our enforcement products, value-wise, that's up over $300,000 on its own for one piece of test equipment.
Wow, I didn't actually know that, Dean. Thank
Yeah.
you. Okay, I think at this point that's actually me done for the majority of the presentation. I'm going to hand over to Dean now to cover the 645, and as Ryan said at the end, we're going to cover the 641 and the 326 as well.
Okay, thank you, Brian. Yeah, so good morning, everyone. As Brian mentioned, my name's Dean Jarvis. Been with AGD, relatively newcomer, only around 18 months or so. Prior to AGD, I spent 5 years working on the highways. Actually, spent 3 years of that as a loop or slot cutting manager. So I've gone from underground detection to overground detection in this role, and I've got sort of 7 to 10 years previous experience in the communications industry prior to that as well. So yeah, don't mind getting my hands dirty. Okay, so we'll jump in. This is the AGD 645. Probably already seen pictures of it. It's a pedestrian weight zone detector. We'll just jump into the next page. So at a glance, this is the AGD 645. Excuse me. You can see there it's a stereo optical sensor. So that just means it uses a dual camera arrangement, very similar to the way that our eyes work. We have a left picture, a right picture, and from the differences between those two pictures, we can actually work out depth perception, things like that, which enables us to reliably detect both moving and stationary targets. Detection zone size, you can see there, it's 33 foot by 10 foot, which is quite sizable when we're looking at crossing sizes. So you can imagine a 33 foot crossing is very sizable, very suited to city centres, built up areas, downtowns, that sort of thing. As I mentioned,
we've got them outside things like colleges, sports grounds, schools. That's the typical sort of application for these detectors.
Yeah. No, that's fine. Yeah, as you can see there, as I mentioned, we can do stationary and moving targets with this unit. Because it uses vision over any radar-based technology, we can detect stationary targets reliably every single time with this unit. The flexible polygon tool, that's our way of being able to set our detection zone super accurate. You'll see pictures of this further on. You might have already seen it on the Coral's website. We're going to a bit more detail on that shortly. Our AGD Wi-Fi Touch-Setup, that is a method of connecting and setting up not just the AGD 645, but our suite of new products. You'll see that's replicated across the 641 as well as the 326 as well. So certainly moving away from our traditional dip switches onto all wireless setup. You can see there, it does speed up installation. We don't need to climb up and down ladders. Reduces the risk from the installer falling. Similarly, with the lack of cables, we don't have trailing cables across sidewalks, things like that, that introduce a risk to pedestrians as well. This unit also has IP connectivity function. What that means is we can hook it up to a network and we can actually do remote monitoring and adjustment over that connection. So you'll see some further info on that later on as well. And this unit also, as you can see there, has an occupancy mode as well. So what this does, it actually looks at the detection zone, analyzes the amount of traffic in there, and it can actually switches outputs differently depending on the amount of traffic there. So what we can do then is use that information to adjust our green man time to allow for more people to cross the road safely. So typical applications, fairly straightforward. This one, you can see there, it is designed as a wait zone detector. So you can see there, we can use it on smaller crossings if we want to take advantage of the occupancy mode, or we can actually use a single detector on our super crossings. You can see there, as I mentioned, those crossings can be up to 33 foot wide. So yeah, pretty much very suited to our city center applications. Just a quick intro into how this unit works. You can see there our wait zone highlighted in brown, and that's our 33 foot by 10 foot area. Our AGD 645 would be mounted on this blue circle here. So what we do when we have a single target in that area, you can see there our output is red, or indicating a low occupancy. With a medium amount of traffic in, our occupancy is now set to medium, and the output varies. And similarly, when we have a pretty much full crossing area, our output is showing, our occupancy is showing as high, and the output is different again. So very basic intro into how that works there. Jump on to the next one. Just a quick one slide on the installation side of this.
Sorry to interrupt, Dean. I suppose perhaps we should just pause to ask if there's any questions at this stage before we launch the physical installation side of things. Any questions from any of the audience? If not, we'll move on.
Yeah, so mountain height wise, we're talking between 3 and 6 meters. I do apologize for this because I don't have the we don't have the foot measurements on here, but I think what is it, about 6'6", I think, a meter, Brian. So we're talking 18 to, let me just work it out a second. Yeah, we're talking
20 foot, something like that.
Yeah, sorry, it's a shade of, yeah, so basically between 10 and 20 feet, that will be as a mountain height. What we found is normally we tend to mount it a bit higher when we're talking about big crossings, just ensures that we get maximum coverage out of the unit. And as with anything, we need to make sure that there's an unobstructed view of the zone. Anything that is in the vision of those dual cameras may affect this operation. Just as a quick note, a little expanded view there. What we try and do is make our products as simple to install as possible. So you can see there, we just have a single bolt to do up there to mount the unit securely. It's quite sizable, that one. And you can see there that we've actually incorporated some alignment marks into the casting of the unit as well. So again, we try to be thinking safety. We try and keep any ladder time as small as possible. So the alignment mark there, as I said, is part of the casting, and we just have a single nut to do up. Just to keep that ladder time to an absolute minimum. Okay, as I mentioned previous, this along with our other units all use the AGD Touch-Setup. So it is a Wi-Fi based setup of all the units. As I mentioned, it's safer than traditional methods, cabled connections, climbing ladders to alter dip switches. The good thing with this as well, there's no additional software required. So the unit is commissioned over via a browser window. We've actually had instances in the UK where people were buying our products and not being able to set them up because their IT department wouldn't allow them to install the software on their devices. So that's why we use the browser-based method to make sure that no one has those issues. So yeah, any device that has Wi-Fi and a browser installed, so we can use laptops, mobiles, tablets, pretty much anything in between, as long as they have Wi-Fi and a browser. And you can see there, we will go into this a bit more. It's just very simple. We connect to the Wi-Fi network, we launch a browser, tap in an IP address, and then that opens up our pages for the commissioning of that unit. Any queries on that, anyone, before we move on? No, lovely. Pardon me. So yeah, we'll just do a step through. This is actually part of our training. So what we'll do, we open up our available Wi-Fi networks, select the one we want. We just untick that just because we have seen issues where people have connected to devices previously, gone away from site, and when they return, some of their devices will connect automatically. Meanwhile, someone else is trying to connect to the unit and they're not able to because unknown to them, there's a device already connected. So we always recommend that that's unticked. Click connect, enter our security key. Very simple. What we've done here, you can see there, AGD645, and the default password is the serial number of the unit. Just make sure that every single unit has its own individual password, and it obviously keeping that connection secure as well. Click next, and then once we're connected, we get a little visual indicator on the unit, which illuminates blue. That just shows that we are connected correctly. Then step 2 is we launch a browser. You can see there Safari and Chrome both supported 2018 onwards. That's really only our 2 recommended units, recommended browsers. Obviously others are available, but we tend to recommend Chrome where available. And what we do, tap in our IP address, exactly as is shown here, and hit enter, and that will take us into our interface of the unit.
Dean, we have a quick question.
Yep.
What if there's no local Wi-Fi in the area?
Sorry, I've just seen that on the chat. The unit broadcasts its own Wi-Fi network, so we're actually connecting to the Wi-Fi network of the unit rather than a public network. Okay.
Okay, thank you.
So yeah, these are actual couple of screen grabs that we've got off some working units. Very typical, crossing to the UK. Certainly, what you guys might see over in the States as well. What we have here, we have a irregular shaped detection zone. This is where our polygon tool comes in useful. You can see there we have a fairly large amount of street furniture, top and bottom, as well as our signal poles as well. So what we can do, there's an unlimited amount of points that we can put into this detection area. So we can make it any size, any shape, anything that you can think of, you can make with this tool. And what that does is it effectively allows us to map out anything that we don't want detecting. You can see in, let's have a look if it works. No, sorry. But up this area here, you can see we've gone around the pole to prevent any permanent detections. Similarly, up here around the railings as well, you can see that we've mapped around that just to make our the unit as reliable as possible. We have a live view on this unit as well, so we can actually see things in real time. And again, as I mentioned, that's replicated over the IP connection as well. And I don't know if everyone can make it out. We actually have a stroller in the second picture here, and you can see the unit. The shaded blue area is the area that's actually causing the unit to go into detect. So we can see the stroller with a child in there is actually being detected. Obviously, that carries over to wheelchairs, invalid carriages, things like that. So, we detect pretty much anything and everything that may be using that crossing. And from development from one of our previous products, which did struggle a bit with shadows, you can see here we have some rather distinct shadows, both from pedestrians and from street furniture here, all of which the unit is programmed to disregard. Okay. All right, lovely. Right, just sorry, move on. So as you might have seen again from the Coral Sales website, as I mentioned just now, this is a picture of how you would use that polygon tool to map around. I think you've seen that pretty effectively in the previous slide. Pretty much just add the dots in where you want them just by simply clicking. We map around the street furniture, map around follow the curb line, and that just makes sure that we only detect the area that we want to. Sorry, we'll just skip through this. I don't think there's any real need. Just a bit of a blow, a close up there of mapping around that pole. And as I mentioned, I think you've seen that pretty clearly on the previous slide. We have undo buttons, so if there's any mistakes made anyway, you can simply go back and start again. That's no problem. Okay, and then once we click next, we do a quick calibration. That's just where we make sure the zone is empty, click calibrate, and within probably about 10 seconds, that writes all the settings to the radar. The radar looks at its detection zone, recognizes that is its default, and once we've done that, we just do a simple walk test on the unit, make sure the unit's operating correctly, and it's recognizing that there's pedestrians in there, or traffic targets, whatever you want to say. Yeah, we just make sure that the unit's operating correctly, and that is pretty much a unit set up and operating. So it is a matter of minutes in that three-step process where we name the site, we map the zone, and then we do a calibration.
Sorry to interrupt, Dean, but there's been a question from Erin. Is can you put a hole in the middle of the zone in case of street furniture? So I guess maybe there's a waste bin or a trash bin in the middle of the weight zone. Can you mask that out?
So what we would need to do in that is you can't put a hole as such, but what we could do is we could say our zone where we put a point at 12 o'clock. We could move down to the center of the picture, map a hole in the center, and then go back up as close as possible. It's a bit difficult to explain. Yes, you could do it, is the short answer. There may be maybe a little dead spot just above the trash can, for example, or the post, whatever it is. But you know, there is a way you could do that. Yes. Okay, as I mentioned, just a quick walk test. We have two visual indicators. So when the unit's in detect, there's a nice bright red outline to the picture, as well as a change in state in the wording down there as well. Right. Okay, so sorry, just reading the chat as we go along. Also, you have the option to redo the setup at any point if needed, or if you return to site and find that it's not quite right, or you know, you're experiencing issues there as well. So what I will do is, sorry, just make sure. Erin, are you okay with that explanation on the mapping of the hole, if you would, or do you need it? All right, lovely. Okay. So as I mentioned, the 645 has an occupancy mode. What this does is, as I mentioned, it looks at the amount of traffic in the detection zone, and it gives us a low, medium, or high output depending on that traffic. So I think a couple of good pictures here, which will explain it better than I do. You can see the picture over on the left-hand side here. You can see there's probably four and a bit targets in there. That will give us a low output. A couple more targets, 5, 6, 7. So we're looking 8 targets there, and we can see that would be a medium output. And as Brian quite rightly mentioned, when it comes to school leaving times, concert, when a concert finishes or a sports event finishes, when we have a dramatic rise in the amount of footfall, you can see there, that is when this unit tends to work at its best. You know, when you have that massive rise and fall in footfall, you can see there the extra bodies in there actually will put that into a high occupancy. The values of these are configurable as well. Basically our yellow zone can only go between 15% on the lower end and 85 on the upper end. The simple drag and drop sliders in the interface just allows very easy adjustment for those. And as you can see there, the 645 is a dual output unit. And what we do is we switch those outputs in a variety of ways to enable, you know, to give us our 3 different occupancy outputs then. Okay, any queries on that before I move on, anyone? Right. Okay, Adam, we're yours. It's not capable of extending the pedestrian time. What the unit does is, if we have one person enter the zone, it will go into a detect state. If more people enter that zone, then it will switch to, if there's enough people, sorry, it will switch to a medium output. And similarly, if it goes, if more people enter again, it will switch to a high output. But this just detects those pedestrians waiting to cross. So it doesn't affect. It doesn't actually extend anything. What it does is change the outputs according to demand, and is the controller's responsibility then to adjust crossing time accordingly. Is that okay?
Just to perhaps reiterate the point there, that the controller itself does extend the crossing time. So it looks at the output, depending on whether it's low, medium or high, and then will extend the crossing time accordingly. So I guess the answer is yes to your question, Adam. It's the controller does it and not the sensor itself. The sensor just provides the outputs to the controller. Does that answer your question, Adam? Okay. Good. Okay. Thank you.
Excellent. So, yeah, as I mentioned previously as well, we have a remote monitoring capability. So we can actually take live video off this unit and feed that back to a central control room all over a network connection. We're not able to stream it over Wi-Fi, just in case anyone asks that, unless we have, a dedicated device on there. But yeah, it's obviously capable of providing live video feed all the time via a wired connection. I don't know if you can see in the background, there are some data analytics available there. I think we might have a little screenshot on that. If not, there's a number of things like percentage of time in detect, and I think it provides outputs per 15 minutes on percentage of time in detect and things like that. So it does help with some analytics if that's required. As I mentioned, reduce fault finding visits as well, so we don't actually need to go to site if there's an issue with a unit. We can simply connect to the unit and see if there's an issue with it, and we can make any adjustments remotely as well if that's required. Okay. Few things. Obviously, we've seen quite a few queries off everyone about getting not just these products but others to do things which they weren't strictly designed for. And off the back of that, we've used the 645 successfully for some alternative detection. So our cycles getting ever more full of carbon, less use of metal. Traditional ground loops don't actually work that well anymore when detecting cyclists. So you can see there, we've actually used this in a successful trial for cycle detection in a designated cycle wait area at a set of traffic lights. Again, very reliable, and we seeing more and more queries for this as well. This is UK based with a right turn. I mean, for you guys over in the US, that's going to be a left turn application, where we actually cross the opposing carriageway or oncoming traffic to get to your destination. So hopefully everyone can see the graphic. This is pointing at the stop line. So it's detecting vehicles as they arrive at the stop line. We've also used it successfully where our vehicles waiting to actually complete the turn. So when the time comes for them to cross the opposing traffic, the units have been deployed to view those wait areas in the intersection, and that trial is ongoing currently, quite close to our headquarters. And that is being hailed a success currently as well. So it is quite a versatile unit, the 645.
Okay, Dean, I think we've got about 15 minutes left now to cover the 641 and the 326. But before we move on, is there any other questions on the 645 that anyone would like to ask? Okay, in which case we'll move on to the 641. Thank you, Dean.
No problem. So yeah, 641. This one should be nice and easy for everyone. This is very much the 645's little brother. Off the back of customer feedback, what we've done is create a more cost-effective unit, which is still capable of providing that reliable stationary target detection at crossings. So again, exactly the same technology where we use a dual camera system. As you can see there, the detection zone in this unit is significantly smaller. So we're down to a 13 foot by 6.5 foot detection zone. What we found is this will satisfy the majority of crossings, and is certainly more suited to our more rural crossings and things where we don't actually have that large amount of footfall as well. Oh, sorry, everyone. So yeah, again, flexible polygon tool. We can detect stationary and moving targets for this. We use exactly the same Wi-Fi method for connection and commissioning. This unit actually has built-in infrared illumination as well. So again, it is more suited to those more rural locations where the street lighting may not be as good, or there could even be no street lighting at all. So we have that infrared illumination just to make sure that the low light performance is what it needs to be. Okay, and again, this should be very similar, very familiar to everyone, sorry. Exactly the same setup. Obviously, we have our smaller detection area here. What we've done, just introduce some street furniture here. And what we can do is, if we find that foot traffic is imposing on our wait area, we can actually effectively mask that out, so we can stop the unit detecting when there is no need to. Obviously, what this does is when we have a target enter, you can see there the unit goes into a state of detect, signified by the red box. And when it comes time for that target to leave, to undertake its crossing, the unit will then revert back to its normal state. Okay, again, I won't go through this, but exactly the same method of setting up, where we connect to the Wi-Fi network, we launch a browser, and we commission the detector. The interface on this is pretty much exactly the same, bearing a few options. Obviously, if anyone gets their hands on it, we find that keeping our interfaces very similar makes everyone feel a lot more the installers feel a lot more comfortable when it comes to using it. There's nothing really that they're not expecting or that they've not seen before. And again, there is a live view available on this one. That is only available via that Wi-Fi connection. So, and again, exactly the same mappable polygon tool as I've showed you in the 645 as well. So it's the main difference is that detection zone size, and we've stripped out the the IP connectivity, the occupancy mode, just to enable us to provide that that low cost, high performance unit. And the last one is our 326. So this unit is a radar based unit, and it is designed for detecting targets when they're actually undertaking that crossing phase. So you can see there, being a radar unit, it does require movement to work, but this will detect targets down to, I've got less than 1 mile an hour there. I believe it's down to about 0.9 mile an hour. We use 24 gig radar technology. It does make it suitable for international deployments. And if I remember rightly, Brian, I think this is undergoing NEMA testing currently, isn't it?
Yeah, that's correct, Dean. Yeah, it's going through NEMA testing in a lab over in the States at the moment. We hope to have that testing finished probably, well, certainly by Christmas, if not earlier.
Lovely. So, yeah, again, exactly the same Wi-Fi setup on this unit. Obviously, the interface is different, considering it's a radar, now a radar-based unit, but the method to connect is exactly the same. And range-wise, this unit is adjustable for length and width, and the measurement is yeah, it can do 79-foot length by 33-foot width. So again, one of our very basic very basic crossings. What we have here, the 326 has been designed to operate in pairs when it's covering a crossing. Main reason for that is you can see here this unshaded zone on the top right of the crossing. And what we do is we get these units to operate in pairs to make sure that the crossing is fully covered, just to make sure that we don't miss any targets. Okay, so if we take, for example, our slow-moving target, our little old lady as target A, and our fitness freak jogger as target B, what happens when they get the invitation to cross? B is straight off the mark, he's onto the crossing, and he is immediately picked up by the unit on the opposing side of the road. Second phase, you can see there what we have is we have both detectors picking up both targets, and similarly in the next phase as well. And in the final phase, you can see there B has now exited the crossing, but A is still on the crossing, and she is continuing to be detected by the unit that's behind her. And in the final phase there, you can see A has exited the crossing. Both units are now out to detect. Okay. Do you want to answer Erin's query there, Brian? If that's okay. Maybe we save it, maybe keep that to
I'll
the
do it
end.
by the chat method rather than talk. You carry on.
Okay, no problem. So again, obviously we put this in just for information. Again, exactly the same method of connection, this unit. No, the only difference is the password that you put in is in a slightly different format, and the IP address that you put in is different. So, but other than that, it's exactly the same. Just to give you everyone an idea of what we'd be looking at, this is an actual screenshot of our interface. You see there what we've done. This has been recently redesigned for our 24 for our 79 foot unit. What we have our live view tracking in this area over on the left. You can see simple drop-down menus to enable us to make quick and efficient changes to any length and width settings. Our transmit channel here, we can actually change the channel that the unit transmits on. Being radar-based, we need to do this to make sure that there's no interference between the units. The front and rear LEDs, we have individual control over those. We also have a timeout option on those as well. Our detection tracks, you'll see in a video that's on the following slide. As I said, we can actually do a live view on this. The detections are shown as little red dots. and we can turn those on or off. We always leave those on. It's very handy when it comes to doing our checks to make sure that the unit is performing correctly. Our mounting position, that's something that we can go into further. I don't think that's required at the moment. And in the bottom right here, we just have a little visual output, or a little visual switch. That's just a visual representation of what state the unit is in, along with a little sounder, which we can enable when we're doing our testing, just to give us an audio guide on how the unit's behaving as well.
Dean, I'm conscious that we've only got a couple of minutes of our allotted time left.
Yeah.
Probably at the point, I think there's only one more slide after this.
Yeah, I was just going to say we've got the video and we should be pretty much done then. So if I just run through the video, we don't need it all, to be honest, Brian. So we just mute that as well because the buzzer is quite annoying. What we do, just give everyone an idea. You can see, how easy it is to interact with this unit. What I will do, just skip forward a bit. That's one of my colleagues just doing a little check. So sorry. So what we're doing is a walk test on this unit. So we can see we're starting in the opposite corner, and you can see immediately that the target is picked up and the unit is tracking his movement all the way down that center line, all the way to the unit. And once that's done, what we'll do is just have a little skip. There's no need to see all of this. This is actually part of our testing procedure. We just like to be thorough. We like to make sure that our units do exactly what they say they're going to do. You can see the red dots appearing as the unit is tracking him again. You can see they're all centered down that near edge. Like I said, just make sure that the unit is accurate and doing what it should be. Similarly, we do a walk test up the center.
I think we need to throw back to Ryan at this point because of our loss of time. So thank you very much, Dean. I was very sorry to interrupt you there. I think we did cover everything we wanted to cover in terms of the presentation. So at this point, thank you very much to everyone for your attention, and I'll hand back to Ryan.
Yeah, so I'll just stop my share as well, if that's okay.
All right. I do want to be aware of everybody's time, but we do have one more question from Adam in the chat box. Can the PED detector be paired with mid-block crossings? So I think what they're asking, if I'm right, Adam, is can this be paired with the 641 to use both with the weight area detection with the crossing detection?
Or is he looking more at, I think he's thinking about rapid flashing beacons and a mid-block crossing. Can the PED detector be used in that layout? So you have the PED detector with the push button on a mid-block crossing. Will it work?
All right. So obviously we don't have mid blocks here, unfortunately, but what we're saying is the 326, are we saying that we push a button, the beacons start flashing, someone enters the carriageway, and that will hold those flashing beacons until they exit the other side? Is that what we're saying?
Typically, yeah. I mean, is that, I think that's what Adam's getting to.
Yeah, I know we've had queries about the rapid flashing beacons before, haven't we, Brian? Yeah, and the way the 326 will detect in sort of X and Y coordinates, so it will detect vehicles traveling along the carriageway as well. So what you've suggested there with a push button would be pretty much ideal, to be honest. So when the push button's not pressed, the unit operates as normal, picking up. The output is ignored. When we press the push button, it then recognizes that the push button is pressed. There's someone using the crossing. It uses that output until they exit the crossing, in which case the beacons then stop.
Yeah, I'm kind of looking at.
There been about snow and heavy rain, how it copes with that?
After feedback from a few of our international customers, the only issues that we've seen with snow is where the snow plows actually would push the snow to an area to such an extent that it thinks it's a person. So that snow is probably around 3 feet deep, if not higher. So as long as color wise there's no issues, but where a plow has actually piled snow into a particular location, it has caused issues then.
Has that answered Adam's questions? I mean, if there's any more, perhaps afterwards, Adam, you want to ask us, you can fire them to Damien and we can answer them separately. If that's all right, Damien and Ryan.
Yep, that's perfectly fine.
Real quick, I do want to just say that with the 326, can that be integrated with the 645 and the 641 to work as a complete system?
Yeah, the 641/645 and the 326. That's how they operate in the UK. We have a combination of those units where we have the vision detectors looking at the weight areas, and then we combine those with the 326 to cover the crossing phase. So that's exactly how they set up and work in the UK.
So if there are no more questions, we will go ahead and wrap this up. Thank you very much for coming. I hope you enjoy your coffees, and we hope to see you at a future session. Thank you again, Dean and Brian, for
No
you.
problem. I appreciate the invite. Thank you.
Thank you for the opportunity, Damien and Ryan. Much appreciated.
Thank you.
Thank you. Everyone have a wonderful day.
Thank you, everyone.
Thank you.
Thank you.
Bye.